All right, this is a bit of a classic. This is a double integral. It looks fairly straightforward, in fact, but it's one that requires a trick, and the trick is something that we test students on a lot. This integral, as written, cannot be done. However, it can be solved by swapping the order. So we can't actually solve this integral. I'll show you why. Let me just switch to my browser. I've pulled up Wolfram Alpha. This lets you do integrals. I've just asked it, what's the integral of sine y squared with respect to y? It's told me what the indefinite integral is. It's come up with this thing called S, a Fresnel integral. The Fresnel integral is a special function. It's actually a useful thing to define. It's useful to define the integral of sine y squared with respect to y as its own function called Fresnel S. It doesn't actually tell us anything. We don't know how to evaluate this integral. If we wanted to stick numbers into it, we would have to use a series approximation to the Fresnel integral, which we can find fairly easily, and we can evaluate it numerically anyway. But that's not actually useful to us at this point in our lives. We want a very nice answer for this integral. So let's think about the region of integration, and then let's swap the region of the order of integration. So we're doing the y integral first in this case. Right, the inner one's the y one, so that's the one we do first. We've got 0 to 1 in x. Y finishes at 1, I guess we know that much, but it starts at the line y equals x. Right, so we start at this line and we go up here. Right, so we get the upper triangular portion of this half. Like cut a square in half, you get the upper triangular portion. If we were to integrate with respect to x first, that is, we choose a value of y, we integrate to this line here. This line is, well, it's y equals x or x equals y. Our x limits would be 0 to y. So let's recast our integral in that order. Y would now go from 0 to 1. When we integrate with respect to x, y is a constant. Sine y squared is therefore constant. We can then just do this integral. It's like integrating any other constant. It's an iterated integral, so let's just go ahead. When we substitute in, that is, of course, this integral is now entirely tractable by substitution. We substitute, say, u equals y squared, du equals 2y dy. So we see that if we had a 2 here, right, we could just substitute du for the 2y dy. Integral of sine u is minus cos u. And that's our answer. And that's elementary, right? Or we always think of cosine as being trivial to evaluate. Cosine 1 isn't a very nice number, but it's something that's a bit better than the Fresnel integral. All right, so this idea of approaching intractable double integrals by switching the order is something you see quite a bit. There's only a few elementary functions that really cause problems, I guess, where, and of course you need the right region, right? This works, the region's a triangle, and we got a y term popping up here when we did our x integral. If that was a parabolic region, we get a y squared, and we wouldn't be able to do the substitution. So these are quite rare and engineered examples in some way, but they do make an interesting little calculation.